Jai Hind everyone, my name is Dr. Dibya Bharti. Today we are going to see some example of mesh analysis in AC circuit. Okay, so we had discussed mesh analysis in our earlier lecture also, but we were discussing the numerical problem on DC network. Okay, so today we will see some examples with AC network. So we had discussed the nodal analysis also. Okay, so we had concluded that nodal analysis is preferable when there are more number of parallel paths in the network. Okay, and when number of parallel paths are less in the network, more number of network elements are connected in series, then the mesh analysis is preferred. And by using the mesh analysis, we calculate the loop current or the mesh current. And if we are knowing the current, then we can easily calculate the voltage across the each circuit element. Okay, so we will continue that discussion. So what is mesh analysis? So mesh is a loop that does not consist of any other loop inside it. So mesh analysis technique uses mesh current as variables instead of current in the element to analyze the circuit. Okay, so that's why this method is absolutely reduces the number of equations that we need to solve. So mesh analysis applies the KVL to determine the unknown current in the given network, and this method is also called as the mesh current method or loop analysis. Okay, so after finding the mesh current, voltages anywhere in the network can be easily calculated. So this was the conclusion of the earlier lecture. So now see, this is the example here. So here 3 network elements, resistors are there and 2 voltage sources are there. Okay, so now first we will solve this by conventional method, then we will apply the mesh analysis. Okay, so here I1 is the current through this R1, I2 is the current through this R2, and summation of both I1 and I2 is flowing through this. Okay, so here I3 is I1 plus I2, I3 is I1 plus I2. Okay, so now if we apply KVL, okay, so we will write 10 equal to 10 I1 plus 40 I3, and I3 is I1 plus I2. That means 10 I1 plus 40 I1 plus I2. Okay, so now this is 50 I1 plus 40 I2. Okay, so this is the first equation. Okay, again if we write the equation in this part, so we can write 20 equal to 20 I2 plus 40 I3. Again, if we replace this equation A, okay, if we replace the value of I3 with equation A, okay, so we will be having 20 equal to 20 I2 and it will be 40 I1 40 plus 40, so it will be 60 I2. So these are the 2 equations that we need to solve, okay, to calculate the I1 and I2, and then summation of both will give the I3. Okay, so an easier method of solving these type of circuit is by mesh current analysis or loop analysis, which is also sometimes called as the Maxwell's circulating current method. Instead of leveling the branch current, we need to level the closed loop currents. Okay, we will level each mesh with a circulating current, and then we will write the KVL equation in the same manner. Okay, so this ensures that the information obtained from the circuit equation is the minimum required to solve the circuit, as the information is more general and can be easily put into a matrix form. Okay, see here, See now the very same equation. See now two meshes are there. Okay, now we have labeled this as mesh 1. Okay, this mesh 1. Okay, this is mesh 2. Okay, we have taken two currents I1 and I2. So now 10 equal to what we will do. This I1 is the individual mesh current of this first mesh. So I1 into 10 plus 40 minus 40 into I2. Why minus? Because 50, 10 plus 40, 50 is the value of the resistance of this mesh, that is the self resistance, and this 40 ohm is the common resistance in mesh 1 and mesh 2. So 50 I1, 10 plus 40 I1 minus 40 I2, because this 40 ohm resistor is the common part between mesh 1 and mesh 2. Similarly, in mesh 2, what is the individual value of the resistor that this current I2 is facing? That is of 20 plus 40, and the current of this mesh is I2. So 60 I2 minus 40 into I1. Okay, so by seeing the network only we can write the equation. Okay, so 10 and 20, these are the voltage matrix term. Okay, so this is the voltage matrix, and this 10 plus 40. Okay, so this is minus 40. Again, this is minus 40, and this is 20 plus 40. This into I1 and I2. Okay, so now if we need to solve this for I1 and I2, I1, I2. Okay, so this is 50 minus 40 minus 40, 60. So inverse of this into voltage matrix, that is 10, 20. This will give the current. Okay, see here both, see this is the very same resistance matrix, and inverse of this has been calculated easily. So this is the inverse. Okay, so now if inverse of resistance matrix will be multiplied with this voltage matrix, it will give the current. So it is very easy to calculate the current, mesh currents, by the mesh analysis method. Okay, mesh or the loop method. Okay, so this is how we have calculated I1 and I2. Okay, so here we gives the voltage matrix for loop 1 and loop 2. I is the loop current matrix and R is the resistance matrix. Okay, so here what is the value of I3? See, what is I3 here? In this case, I3 is I1 minus I2. I1 minus I2, because the direction that we are assuming for I3, according to that, I3 is I1 minus I2. Okay, so now see, we have calculated I1 and I2, so we will calculate the I3 also. Okay, so this has been calculated as 0.286 ampere. See, so basic process for calculating the current with the mesh analysis is that first step is to label the internal loop with circulating current. Okay, I1, I2, I3, or label the mesh with the individual circulating currents. Okay, then write the column matrix for the voltage. Okay, write the resistance matrix. So R11 is the total internal resistance of the first loop, and so on. Okay, suppose there are 3 meshes. Okay, so RNN is the total resistance of the nth loop, and so on. So RJK the resistance which is directly joining the 2 loops. Okay, so write the matrix or the vector equation V equal to R into I, then solve the equations. Okay, so here now we will see mesh current method. Okay, see here 2 one voltage source and one current source is there. Okay, so now how we will solve this by mesh analysis? So in earlier lecture also we had seen the definition of super mesh and super node. Okay, so now this concept will come. So when a current source exists only in one mesh, see here, this is the 10 volt voltage source and 5 ampere current source is there. Okay, so here if we write the equation in this mesh, first mesh, 4i1 plus 6i1 minus i2 equal to 10. Okay, and in this second loop, okay, how we will write? Okay, so here we can see that 5 ampere current source is there and the i2 is flowing in this direction. Okay, in this direction. So that means I2, by seeing this only we can see I2 is minus 5 milliampere. So now if we put the value 10 here, what is this equation? 10 I1, this is 10 I1, okay, minus 6 I2 equal to 10. Okay, so now 10 I1 is 10 plus 6 I2. So now 10 plus 6 into minus 5. So it will be minus 20. That means current I1 is minus 2 ampere. Okay. So now see here, this is the example where concept of super mesh will come. Okay, see here, in between two meshes, here what is the case? Here current source is there in the mesh, but it is not in the common part. Okay, but here a current source is there in this common part. Okay, so when current source exists between two meshes, this is called the super mesh. Okay, so how we will write the equation? Okay, in the mesh. So here two mesh currents I1 and I2 are assumed. Okay, so now how we will write the equation? See, what we will do, we will write the equation in this part only. Okay, and in this part. Okay, so see, if we exclude this part, this will be the network. Okay, so if we write the KVL equation, it will be 6 I1, okay, 10 I2, 4 I2 minus 20 equal to 0. So it will be 6 I1 plus 10 I2, okay, plus 4 I2 minus 20 equal to 0. That means 6 I1 plus 6 I1 plus 14 I2 equal to 20. Okay, so now this is the equation. We can write this as 3 I1 plus 7 I2 equal to 10. This is the first equation. Okay, so now here I1 is in this direction, I2 is in this direction. So we can write I2 minus I1, I2 minus I1 is 6. Okay, how? See, this direction of this current source is in upward direction. So I2 minus I1 equal to 6. Okay, so now we are having the two set of equation. Okay, so we will solve this and we will find the value of the currents I1 and I2. So this is the case of the super mesh, because in between two meshes current source is existing. Okay, so when, see here, mesh is there with the dependent source. Okay, so this is the 5 ohm current source, 5 ohm resistor, this is the 4 ohm resistor. Okay, this is the 20 ohm resistor. Here 75 volt independent voltage source is there, and here 10 ix, that means it is the current dependent voltage source. Okay, this is the voltage source. Okay, so now see, two mesh currents I1 and I2 are assumed here, I1 and I2. So now we will write the equation. So 5 I1 plus 20 I1 minus I2 equal to 75. Okay, in this mesh, okay, 4 I2 plus 10 Ix. Okay, this is the current Ix. Okay, so 4 I2 plus 10 Ix plus 20 I2 minus I1. So here Ix is I1 minus I2. Okay, so now we are having, suppose this is equation number 1, this is equation number 2, this is equation number 3. So we are having the 3 equations and 3 unknowns are there, I1, I2 and Ix. Okay, so we will solve this and we will get the solution. This is another example. Okay, so here use the mesh current method to find the I0. I0 is the current through this resistor and V0, 0.2 V0. Okay, so this is voltage controlled current source. This is the example of voltage dependent current source. Okay, so here see, this is the solution. We had assumed the currents. Okay, see here, this is the current dependent voltage source. Okay, and this is the voltage dependent current source. So now we had assumed the, see, I0 is the current through this resistor and V0 is the voltage across this resistor. So now we will assume the mesh currents. Okay, so here 4 individual meshes are there, 1, 2, 3 and 4. 1, 2, 3 and 4. 4 meshes are there. So we had assumed the 4 mesh currents, I1, I2, I3 and I4. Okay, so now here this has been, equations has been, can be written easily. Okay, so now see here, for the second mesh we can write 10 I2, okay, plus 4 I0, 10 I2 plus 4 I0 minus 10 I2 minus I1 or minus 10 I0, minus 10 I2 minus I1. Okay, this can be written. So here at node A, see here at this node, okay, at this node A, I0 plus I2 equal to I1. Okay, so see, this is the equation now. So by solving this equation 1 is now this. So I1 is 16 by 6 into I2. So here again, if this is the case of the super mesh, okay, because we cannot write the KVL equation in this part. Okay, we cannot write the KVL equation in this part also. That means we will have to apply the KVL equation in this part. Okay, so in super mesh we can write 50 I1 now minus 4 I0, 50 I1 minus 4 I0. Okay, so plus 40 I3. Okay, plus 40 I3. Okay, so now 40 I3. Okay, so here also 50 I1, 10 I1 minus I2 minus 4 I0 plus 40 I3 equal to 100. So now I1 and I2 are directly related. So now we will simplify this equation. Also here see, this is I4, this is I3. So we can write I3 minus I4 as 2. Okay, so I3 minus I4 as 2. So now I4 minus I1. See, I4, this is the I4 current, I4 and I1. See, I4, okay, so I1 minus I4. I1 minus, this is 0.2 volt, 0.2 V0. Okay, also what is V0? V0 is, see, V0 is the voltage here. So V0 can be written as V0 is 10 into I2. V0 is 10 into I2. So now equation 1, 2, 3, 4 and 5 we are having. Okay, so now we will solve this equation and then we can calculate V0 and I0. Okay, again here another example is there. Okay, so here this is the current dependent voltage source. This I0 is the current through this resistor. Okay, this there are, see in this example, see there are 3 meshes. So we had assumed the 3 mesh currents I1, I2 and I3. So now we will write the mesh equations. So in the first mesh we can write 10 I1 minus I2, 10 I1 minus I2 plus 12 I1 minus I3 equal to 24. Okay, so this is the equation. Okay, so in second mesh 24 I2 plus 4 I2 minus I3 plus 10 I2 minus I1. So this is the second equation. Okay, so now in third mesh we don't need to write the equation because we can directly relate I0 as I1 and I2. So I0 is I1 minus I2. See, I0 is in this direction, I1 is in this direction and I2 is in this direction. Okay, so I1 minus I2 is the I0. So this is the third part. Okay, so by putting the value of I0 as I1 minus in this equation, see in this equation 4 I0, this is the voltage source, so 4 I0 plus 12 I3 minus I1 plus 4 I3 minus I2 is, this is the third mesh equation, and I0 is now I1 minus I2. So now put the value of I0 as I1 minus I2. So I0 is I1 minus I2. So now this equation 3 will become this. Okay, so now these 3 equations are in the form of I1, I2 and I3. So minus 11, minus 5 and minus 6. Okay, minus 5, 19, minus 2. Minus 5, 19, minus 2. Here after solving this, this is the equation number 4. Okay, so minus 1 and 2, I1, I2 and I3. So now you can solve this for calculating the currents I1, I2 and I3. So this was about the discussion of the mesh analysis. Today we had seen mesh analysis, okay, in circuit where the condition of mesh, super mesh was there. Okay, we solved the problem where dependent sources was there. Okay, so this was all about the today's discussion. We will continue our discussion in next lecture with some other topic. Thank you.